Good morning, student. Today we are going to learn about amplitude shift keying. This is also known as ASK. After the completion of today's session, you are able to define amplitude shift keying and explain the generation and detection process of amplitude shift keying. So, in ASK, frequency and phase of the carrier wave is kept constant and only the amplitude is varied according to the digitized modulating signal. It is also referred as binary amplitude shift keying, as its usual operation is associated with only two levels, that is 1 or 0. In this method, there is only one unit energy carrier and it is switched on and off depending upon the input binary sequence. Means when we give 1 at the input, then only at the output we get the signal. But when 0 is given at the output, we don't get any signal. This one is the ASK waveform equation, that is S of t equal to root 2 ps cos 2 pi fct. As I discussed that at the output we get the carrier signal when 1 is given, and we know that the equation of the carrier signal is A cos omega ct or 2 pi fct also can be written. So A, this one is the amplitude. So power dissipation P equal to A square by 2. So from this equation we can get the value of A, that is A equal to root 2p. So this value is used here and finally we get this equation, that is root 2 ps cos 2 pi fct. So this is the waveform. The first figure represents a message signal in the form of the bit stream, means digital signal. Then the second one, this figure shows the carrier wave whose amplitude is to be varied according to the digital message signal. Then the last one, it shows the resultant ASK waveform which is amplitude modulated. Here we can observe that the signal is present only in case of the high level bit stream and no signal waveform is present when the bit shows a low level. It's showing on and off behavior. So high level digital stream means 1. When 1 is given, at that time we get the output. But when the bit stream is low level means when it is 0, no signal waveform is present. Here you can observe all the bit like this. Then as it's showing on and off behavior, it is also known as on off keying. Okay, so if someone give you a bit stream and ask you to draw the ASK waveform, so this one is the example. Here a bit stream is given and we have to draw the ASK waveform. So first we give some dotted line. So when 1 is there, only at that point we get the output. When 0 is given, No output is there. I am not able to do the diagram properly here, but from this diagram you can able to understand the basic things, that when 1 is given, only at that point we get the signal, and when 0 is there, no signal is present. Like this, whatever the bit stream may be given to you, you are able to draw the ASK waveform. Next is the generation of ASK. So here the block diagram consists of a, we can say, multiplier or product modulator, whatever that may be, or balanced modulator. So consists of a balanced modulator and a band pass filter. There is two input signal given to the balanced modulator. One is the incoming bit stream, that is a digital signal, and another one is the carrier signal. So the balanced modulator multiply the signal and give the output, and that output is given to the band pass filter, and that band pass filter is act as a band limiting filter. It shapes the pulse depending upon the amplitude and phase characteristic of the band limiting filter. So here this balance modulator act as a switch, okay, a simple switch. When 1 is given at the input, only that time the switch becomes closed, and due to the close of the switch, the carrier signal reached at the output, okay. But when 0 is given, the switch remain open. Because of that, no carrier signal reach at this output, so here we get no signal. So like this, at the output of the balance modulator we get the signal when 1 is given, and when 0 is given, no output is given, no output we get at the output of the balance modulator. Then band pass filter helps to shape the signal, and at the output we get the ASK modulated signal. Next is the detection of ASK signal. Detection means demodulation. So demodulation is the recovery process of original signal from the ASK modulated signal. So two types of techniques are used, that is coherent detection and non-coherent detection. First is the coherent detection. Coherent means same carrier signal is used in transmitter and receiver, or we can say the carrier signal used in the receiver section is same as used in the transmitter section. So the block diagram consists of a product modulator, integrator and decision device. So here the incoming ASK signal is applied to one input of the product modulator, and to the other input of the product modulator we give a carrier signal, okay. Then the output of the product modulator given to the integrator. Here the integrator operates on the output of the product modulator and performs a low pass filtering action. Then the output of the integrator goes to the input of the decision making device. Then the decision making device compare the signal with a preset threshold. Preset means predetermined value, okay. So we compare the signal with the predetermined threshold value. It makes a decision in favor of symbol 1 when the threshold is exceeded, and in favor of 0 if it is lower than the threshold. means it threshold is lower than the input signal given to the decision device. Okay, so this is all about coherent detection. Next is the non-coherent detection. So in coherent detection, synchronization is given. Because of that, we use the same carrier in transmitter and receiver. But in non-coherent detection, there is no synchronization is required. Because of that, no carrier signal is used in this method. So the circuit or the block diagram of the non-coherent detection is simpler than the circuit used in the coherent detection. So non-coherent detection block diagram consists of band pass filter, then envelope detector, then decision device. Band pass filter give a band limited signal at the output. Then the output of this filter is given to the envelope detector, which is the combination of rectifier circuit and low pass filter. We already discussed in amplitude modulation, demodulation of amplitude modulated signal, the brief explanation of envelope detector where a diode is used and a low pass filter is used to give the demodulated signal. The same function here also applied. Then the decision device, the function of this decision device is similar to the function of the decision device that is used in the in coherent detection here. Okay, so at the output of the decision device we get our proper demodulated signal. So this is all about ASK, amplitude shift keying. Thank you.